Hey Micah, gonna try and film a short little video for you here to help you out with this problem. First off, this problem is really badly worded, like it sucks and it's confusing. I'm just gonna help you set it up and figure out what the answer is real quick. So basically, it helps when you're starting a problem like this to write out everything that you know. You know that the total distance the kayaker travels, let me write that a little lower. You know the total distance is 2 miles, so you could say the d equals 2. You know the total time it takes them, 3 hours and 20 minutes, but assuming it wants the answer in miles per hour, so you're just going to want to convert this over to hours. So it's 3 1/3 hours, or 10/3, which is what I'm going to use for this video. So it's 10/3 hours for the full trip. And then the tricky part of this is the speed, and that's where the wording is bad. So there's an equation that you can use for this problem too. Don't know if you've learned this yet, but it's distance equals rate times time. And the tricky part here is finding out what the rate is, because the problem tells you about the current of the water being 3 miles an hour, and that's not really the rate you want to use, but you need that to help you find the answer. So the paddlers are moving at a constant speed the whole time. They're paddling at a constant rate. But depending on whether they're going upstream or downstream, the actual speed they're going to be moving at is going to change. I don't know if that makes sense. But basically you have to factor in which way the water is flowing for when they're moving downstream and upstream. And so you actually have to split up the distance into the mile where they're going downstream and the mile where they're going upstream. And so you're going to end up with sort of two equations here. So here's an example of what I mean. So for when they're moving downstream, there's your distance in the distance part of the equation. They're moving downstream for a mile, and it's going to take them half of what the time is up here. So 10/3, half of that is going to be 5/3. So it takes them 5/3 hours when they're going downstream. And the rate they're moving at is going to be whatever the rate they're paddling at plus the water flow. And because you're moving downstream, it's going to make you go faster. So you're going to add that 3 miles an hour from the water current. I'm just going to write that over here too. The water current is 3, just so I don't forget. And then when you're going back upstream, you're going to have a similar thing. You're traveling 1 mile upstream. It's going to take you 5/3 hours, but this time it's going to slow you down. So you're going to write -3 in here. And then basically all you have to do is isolate x. And actually either of these equations will give you the right answer. I'm just going to give you the bottom one here because I have more space to work with. Basically the first thing you'll want to do is get rid of that 5/3. So you'll divide both sides by 5/3. Those will cancel. When you're dividing by a fraction like that, you can flip the bottom one and it'll become the answer. So this was actually just 3/5 equals x minus 3. And then all you have to do, add that 3 to the other side. So we'll move up here. So 3 plus 3/5 equals x. And then 3 is equal to 15/5. So that's 15/5 plus 3/5 equals x. So your answer is 18/5, or 3.6 miles an hour. And that's the rate that they are traveling. If there's any part of that didn't make sense, or you want something to get clarified, just let me know. I understand the fractions are kind of confusing. That's just a personal choice. You could use 3.333 when you're doing this problem if it makes more sense to you. But yeah, that's how you'd solve this problem. It's just a really difficult one to set up.